In this lecture, we'll look at the content features supported by bada. First of all, many bada users want to know what a content is. Let me answer this first. Content can be viewed as referring to all the files on the device. They can be audio, video, image, or any other file type. A handset user will operate on these files for his or her infotainment needs. The user can put files onto the device, remove unwanted files, and view them. Users may want to group them or sort them. All these basic needs of the device user are served via functions provided in Content module of bada. The Content module details can be grouped into 4 basic parts based on the activities done to the content, namely Manager, Search, Transfer, and Metadata. These functionalities are implemented in the Content Manager, Content Search, Content Transfer, and Content Metadata classes. Let's look at what function each class does one by one. The Content namespace manages the 3 most common media types: image, video, and audio files. All other types of content are categorized as other content. Content provides functionalities such as creating, reading, updating, and deleting content on the device. This functionality is provided by the Content Manager class. The Content Search class provides the functionality for searching for device content. Downloading content from a public server can be done using the Content Transfer class. Metadata gives information about a content item, such as when that file is created or updated. And if it's a multimedia file, information such as the artist and genre can be accessed. Let's look at the Content Manager class now. All content and their attributes that are stored on the device are represented as content information. Content can be classified into the 4 major categories: image, audio, video, and all other remaining types are grouped into other. Content supports the classification of files based on the file format, keyword, type, and category. Content supports all the basic information about the file, including the name of the file, the size of the file in bytes, the description of the file, the author, and when that file was created. Additional information about user tags in the file can also be created, for example, the provider, rating, etc. Each media type has some specific attribute. For example, image media files have the width, height, and title of the image in the content info item. Audio files have the artist, composer, genre, etc. Video files have the artist, audio bitrate, video bitrate, genre, and etc. fields. As discussed earlier, creating, deleting, reading, and updating content can be done using the Content Manager class. Using the Content Search class, we can easily search for content using SQL, like syntax. For example, artist equals Mr. X. This query is checked while picking and listing files from the content database. Downloading content from a public server can be achieved using the Content Transfer class. The Content Manager class manages the content on the device. It creates content information for new content in the content database and reads, updates, or deletes the existing content information. This class includes various attributes, such as user tags and metadata, which are extracted from a physical file. When a user creates new content, its content information is created as a new pair. There are 3 ways the user can register the content on a bada device. First, the user has to create the content info information and has to use the Create Content API, where we have to pass the created content info information. Second, the other method. For example, the Create Content method, which has source path, destination path, delete source, content info as the input parameters, which are easier to use. The source path can be the /home path. The destination path can be the /media or /storage card /media path. The source path can be moved or copied based on the delete source variable value. All file operations and content creation will be handled internally. Third, if the file is present in the buffer and content creation has to be done for this, then you can use the Create Content API with the byte buffer, destination path, and content info parameters. The destination path should start with /media or /storage card /media. When a user deletes existing content, its content information is deleted from the content database, and also physical files will get deleted. To get the content information, you can use the Get Content Info N API. Using the Update Content method, specific content information can be updated. Now, we're going to look at how to use these APIs in bada applications. To manage the content, the files must be located in the /media or /storage card /media directory. Let's have a look at the code now. Here, I constructed the Content Manager instance. Then, I constructed the Image Content Info instance using the img.jpg image file present in the media /image directory. Then I pass the Image Content Info instance to the Create Content method of the Content Manager class. This will create a content item for that image file, and the returned ID is the content ID. Here's an alternative method for creating content available from bada 2.0 onwards. First, we construct the Content Manager object. Here, we have to use two file paths. The source path is the file which is in the home directory of the application. The destination path is the path where the content will be created inside the media image directory. Then, when we call the Create Content method with these parameters, a content item specified by dest_path will be created for the image specified by source path. The third Boolean argument is for deleting the source file or not, and as we specified false, the source file will not be deleted. Now, let's experiment with updating and deleting. Here, we're first going to check if the ID is valid. After checking this ID, we want to work on image file information. Then, we retrieve the Content Info instance using the GetInfoN method. We can always check for the content path and print this value in the SDK, as here it's shown for printing the content path. In order to set some keywords to the image, the setKeyword method is used with the apple and fruit keywords. After that, it's necessary to call the Update Content method so that the content will be updated in the database. Then, if you want to delete the content, you can call the Delete Content method, and this method needs the content ID as the input parameter. Now, let's have a look at the content search. The content search class can be used to retrieve distinct values for specified fields. For example, the audio artists, genres, albums, etc. Or search for a particular content item with some conditions. The search is performed using the search_n method exposed by the content search class. This method supports various types of retrieval methods through its arguments. For example, if we add page equals 1 while searching, it will search only the first page of the content database. Similarly, count per page refers to how many files should be listed from the first page. For example, a maximum of 5 files on the first page with matching conditions. The search result includes the total count and total pages for the conditions, and this is viewed as the content search result class. The total page and total count values show how many pages there are in the content database and how many files are present in the content database, all together with the matching condition, where the expression carries an SQL-like query to the Search API. Let's look at the example code for a content search of the files on the device. First, we need to construct the content search class, and here I've used content_type_audio as the example that will search for audio contents. The input parameter, page no, specifies the search only first page option of the content database, and count per page specifies a maximum of 5 files that will be listed on that page. Total page and total count are output parameters, and those are filled by the Search API. It shows the total number of pages and the total number of audio files from the content database which matches the query. The return value of the Search API will be a content information list, and the pointer of the iList class holds the information of the searched files. Now, we're going to call the search_n API of the content search class instance. The query says, list all audio files where the artist is Rain and the genre is dance. The last two variables mean sort the searched files in descending order of their released year. And last, when you're finished with the search results, this is how you release the memory by clearing the list using the Remove All API, which will clear the content information of all searched files in the list returned by the Search API. Then, we also need to delete the list. Let's have a look at transferring content now. This picture shows the purpose of the Content Transfer class. If you want to download an image on a public server with the address http://static.bada.com//images/list_img01.jpg. You can use the content transfer methods to download the file to the bada device. The content registration of the file sunset.jpg will be handled internally by the download method of the content transfer class. After the download, this file will be visible to all applications and the phone's internal memory. The Content Transfer class provides an interface to interact between bada handheld devices and a server on the network. The Content Transfer class supports HTTP downloads from any server that supports HTTP access. Content transfer APIs are processed asynchronously due to the latency and indefinite time for data transfers between the server and the device. The result of the called APIs can be known by the iContent Transfer Listener interface, which calls registered functions of the client when the server completes the requested service, or status notification during an ongoing service. A download can be done from any HTTP server. The progress of the download operation can be monitored by its list. The content transfer methods need the content_transfer privilege. The main APIs in this class are download and download to buffer, which download a content file from the contents provider's server, and download a content file to a buffer on the content provider's server, respectively. The point to be noted is that the download to buffer method does not register the content. Let's look at metadata now. Metadata such as EXIF and ID3 tags can be extracted from image, audio, and video files. The media file contains metadata separate from the media data, which has a few details about the file. These attributes of the media files will differ slightly between each other across media types. The classes representing metadata are image metadata, audio metadata, and video metadata. Let's look at what all the attributes of each of the media types contain in their metadata section. Audio files have attributes such as album name, artist, the audio bitrate, composer, genre, year in which it's released, and title. These details can be queried via functions provided by the audio metadata class. Image files have attributes such as height, width, and title. These image details can be obtained by the image metadata class. Video files have attributes such as the artist, audio bitrate, frame rate, genre, height, title, video bitrate, and width. These individual values can be obtained by functions of the video metadata class. To summarize all that we've learned from this presentation, here are the key points. The content namespace provides access to the content database on the bada device. Content is a searchable database on the device with media content-specific properties, such as the artist, genre, etc. Content transfer allows the downloading of content from a public server. The image, audio, video metadata classes can be used to retrieve the metadata of local content on the device.